Okay, so for this video, we're working on the note-taking guide for lesson 7.1, which is going to introduce exponential growth functions. So we have some definitions to begin. We're going to get those in and then actually see what these are and what they look like. So the first definition I've typed in already, and I need to add a little mark that's really important right here, because it should be, that's not right. It should be A is not equal to 0. And please take note that that A, B, this is actually saying I'm limited in word processing for what I've got here. This is y equals A, B to the x power. So that's what that's actually showing you there. Don't be confused by the caret. So x is in the exponent is the point. So you might want to pause it and write that in, and we'll move forward. But x is in the exponent, and the base of x is b, and b is got to be a positive number, has got to be positive. And you see our old friend a here in front. All right, so go ahead and write that down, and I'll be pause if you need to. Our next definition is specifically for exponential growth functions. We will also be learning about exponential decay functions in the next note-taking guide. So an exponential growth function occurs when you have a, the a value is greater than 0. So think about what that means. Greater than 0. It means it's positive. So when a is positive, and when b is greater than 1. B can be a fraction. So we're saying b has to be greater than 1, not just positive, but for exponential growth, a is going to be positive and b is going to be positive. So when both of those are positive, we have exponential growth. And again, we're looking at the function as y equals ab to the x power. So again, you might want to pause to write that down. Our next definition is for growth factor. So in our equation, our exponential equation, the actual base of the exponent, which in this case we're calling b, is the growth factor. What we will see is that sometimes b isn't just one thing, but it's an expression. So it could be x plus 2, or it could be, 3x minus 5, or it could be 1 minus 2x. It could be any kind of expression. So, but that part, the actual part that's raised to an exponent, is the growth factor. So if you haven't written that down yet, you might want to pause. And our last vocabulary word for this lesson is asymptote. An asymptote is a line that your graph, remembering that the graph is what you're drawing, the picture of the function. So it's a line on the graph that your graph is approaching more and more closely. And for our purposes this year, it will never touch it. It will never cross it, okay? Now, as you go along in math, you'll see some asymptotes that approach it in a different way, and they might actually cross it. But in general, for us, it's going to be a line that the graph is approaching but does not touch. It just gets infinitesimally close. All right, so moving on to looking at the exponential growth function and what it actually then, how it behaves. And so we start, as we often do, with the parent function. And so the parent function in this case is y equals b to the x, where b is greater than 1. So this is greater than, sorry. That's the parent function for the family of exponential growth functions with the base b. Now, generally, when we write a parent function, we say, well, write the simplest parent function, or write the simplest function of this family of functions. So the actual simplest function we can write for this is y equals 2 to the x, and that's commonly used as the parent function for exponential growth, because a base of 1, again, won't work, because as we put numbers in for x, we would just keep getting outputs of 1. A base of a fractional number isn't actually exponential growth, so therefore we use 2. And if you look at this graph that's shown here on the page, that is actually the graph of y equals 2 to the x power. But we're going to notice some things about this graph. First of all, the graph is starting very, very, very close to the x-axis. As a matter of fact, it looks like it might even be touching the x-axis, but it's not. It's just getting very, very, very close. And if we could pan to the left and see this graph even farther to the left and farther to the left, this graph will continue to get closer and closer and closer and closer to the x-axis, but it's not going to touch it. Then it goes through a couple of points they have plotted, and then it's just heading kind of in a gentle curve up and to the right. And that is generally what an exponential growth graph will look like. The x-axis in this case is the asymptote. And so normally we draw the asymptote on the graph with a dashed line. So I'm just going to add a dashed line to this along our horizontal or x-axis. And that is that line that our graph is approaching. Okay? The domain of this function is it's going to the left forever, it's going to the right forever, so it's all real numbers, and I'm just going to use our symbol for that. The range, though, is restricted. The range is restricted because of that asymptote. You can think of that asymptote just like being a wall that the function can't get past. So therefore, since our asymptote is at the x-axis, the range of this function we can write as y is greater than 0. And you have to make a note of the fact that it's y is greater than 0, not y is greater than or equal to 0. Because y would only be equal to 0 if it touched the x-axis, and it's never going to. We could also write this range a different way. We could say 0 is less than y, which is less than infinity, less than or equal to infinity. So that would be an alternate way to write it. Either one is acceptable to me for this, as long as you don't have that equal sign, because y will never be equal to 0. All right, so now we're going to graph our first function. I don't think I've mentioned this. I have to apologize for these little boxes you see on the screen. It was just part of the changing this so I could write on it on the computer. It did that. So don't let it distract you. Look at your note-taking guide, and I think it's perfectly clear. Okay, so the note-taking guide here suggests that the easiest way to graph this, and I'm going to agree with it, is to begin by putting in 0 for x. So I go to my equation, and where the x appears, which is of course in that exponent, I'm going to put a 0 for x. Our a value for this function is 1/4. Our b value is 6, which of course is greater than 1. So now to evaluate this, it's actually very simple, because 6 to the first power, I'm hoping you remember, is 1. 6 to the first power equals 1. So what we have here is actually 1/4 times 1, which of course is 1/4. So our point that we're plotting is 0, 1/4. So I'm just going to come over here to my grid, and I'm going to go to 0, and approximately 1/4 might be there. Okay, so that's my first point. To get my next point, I'm going to take the next easy number to put in for x, which is 1. So we're going to put in to our equation y equals 1/4 times 6 to the first power. Okay, well 6 to the first power is 6, so I'm going to put 6 over 1, so I can multiply straight across. 1 times 6 is 6, 4 times 1 is 4. We're going to reduce that fraction to 3/2. So when x is 1, y is 3/2, which is 1.5. So I'm going to come over here and go to on my x-axis to 1 and up to 3/2. Okay, so we're going to draw a curve. We remember the shape. We can look up at our other graph. It's a nice curve that begins just above the x-axis. and passes through the 2 points and then moves up and to the right. And it's not going to suddenly shoot off to the right like a crazy thing. It's just going to gently curve. So this is a little tricky for me to draw on here. You have to be a little understanding, but I'm going to start very close to the x-axis. Whoops, that was a slip. That didn't work. Try that again. All right, we're going to begin just above the x-axis. We're going to go through our points. This is not a very nice curve. I wish it was better, but that's the idea of it, okay? This should not be like a dot to dot. It should be a nice curve in here, okay? But do notice I don't let my graph touch the x-axis. I'm trying to indicate I understand it stays above the x-axis. I am going to draw my asymptote, which will be a dashed line, in this case along the x-axis, so we see that. Okay, that's that graph. Feel free to go back and watch that again if you need to. I hope you can draw better than I do. So now we have a new equation, and this time our equation is more complete. We've got h, we've got k, along with a. So we know about h and k. Notice that h is in the exponent with x. H is always wherever x is. H is going to do the same thing it always does. It's going to shift our graph in the opposite direction that it looks like. K, as always, is off here by itself, and it's going to do as it always does, exactly what it says. It's going to shift the graph down to. So I don't like the order they tell us to do this in the note-taking guide here, so I'm going to mark this 1. The number one thing we want to do is translate our graph using h and k. So since h here is 2, notice it's always the opposite, and k is -2, I'm going to translate the graph right 2 and then down 2. And I'm going to put that point right 2 and down 2. And now I'm going to take those same x values that we used before, and I'm going to do like we did in the last unit. I'm going to draw a little box around this part because I've used h and k. I've taken care of those when I drew this dot. All right, I'm going to run out of time, and I don't want to do that in the middle of this. I kind of already am in the middle of this, so I'm going to stop this video. You need to pick this up at the next video because I have to keep these short.